Hi everyone! You may already know everything that is on the desk in front of me, which is my 3D printed rocket I nicknamed Printo. It's made from PLA plastics and obviously is printed in 3 parts. I already flew it, which you can watch, I think it's that upper corner, and we had a little problem with throwing out the parachute with the built-in charge from the motor. So today I want to solve this problem by easily giving the parachute more room to move. There's not too many things I could do about that. I can't make this bigger, it's already printed and I want to redesign the whole rocket. So I decided I just go ahead and print myself a little, what you could call an adapter or extender that fits right between the lower part here and the upper part here, giving me about 4 more centimeters to put the parachute in so it's not as stuffed. Yeah, and that's what we are going to do today. So the first things first, we obviously sadly have to cut this somewhere. I don't want to cut it here because that's where all the parachute assemblies. I'm just gonna go ahead and cut it right about here, praying this is not a stupid idea because I don't think I have too much more Kevlar. This is Kevlar string, by the way, because it can survive very high temperatures. You can see right here all the black stuff. That's from the engine discharge. When that goes off, you really don't want to have everything burning. So you use Kevlar, and only up there things like rubber, and in between usually you have something like this, which is an old piece of pants. So I cut one side, and I have to cut the other side too, I believe, because of my unbelievable smart construction here. And now we can take this all apart. As you might be able to see, I glued these parts together, and they are now, after they broke apart after a little crash landing, still quite greasy, and they have all that glue left over on it, and so I want to get rid of that. Beautiful smell of sulfur coming out of that little pipe here. Alright, I gotta try to work more in the middle of the desk. Camera sadly isn't perfectly in the middle of the desk for me, but well. So the next thing is to see if this even fits. This is quite interesting because if I did some mistakes here in remembering the right values, then this might get quite awkward quite fast, but beautiful. It's a tight fit. I'm not gonna push it all the way, because we want to take it apart and glue it, obviously. Just want to see if it fits at all. Put this through here. Let's see. Up here we have a fit 2. Beautiful. Maybe I gotta clean that up apart a little bit more. As you can see, the diameters aren't perfectly the same. That's a little bit bugging me, but well, nothing I can do about it. Also, I printed this middle part in only 0.3 millimeters resolution on my 3D printer because I printed it with, well, the thing you are hanging off right now. Printed myself a little cell phone camera hold to make this kind of video. So yeah, I printed all at the same time. It's all the same resolution and obviously not the same as the rocket, which I think I printed in 0.05 or was it 0.15 millimeters? I can't remember quite exactly, but far better resolution to keep all the grooves on the material to a minimum for better aerodynamics, because that's what's probably gonna eat most of the speed. So gluing it together is actually kind of simple. We just need glue and put it together, right? Right. For glue, I chose epoxy glue. I fell madly in love with that stuff after repairing my Atmoventus and Casmo X rocket, which you can also watch up there if I'm not too stupid to put that in. It's 2 components glue, so just mix them together, and within 5 minutes that stuff goes quite hard, and after something like 20 minutes or an hour, you literally can't get it apart without completely breaking what, well, is exactly what happened over there. So I'm gonna mix it in here. We want about 50-50 glue and hardener. And this is the hardener, so we want about the same amount. There. And now we're gonna mix it together. It smells quite funny. So what this epoxy glue essentially is it's liquid plastic. You can imagine it like Lego. One of them has all the Lego parts in it, and the other tube has a bunch of crazy builders in it. So when you mix them together, all the builders go completely nuts and put all the Lego parts together and create solid plastic. And that's what this stuff is. Yeah, beautiful. There's a bunch of stuff coming out on the side, and I just realized I put all the glue on myself. I'll be right back. Right, nothing some paper towels can fix. Oops. The annoying thing is, as I said, this creates literally plastic from two liquids, so you really do not want to have it on your skin. Not only because it isn't the healthiest thing to have on your skin. I don't think that any beauty YouTuber would recommend that stuff. But also because when it's solid, and you ain't gonna get that stuff off your skin too well again. Alright, so kinda, does it look straight to you? I think it is. It's quite fine. So that's the first one. And let's see if we have enough glue and enough time, because that stuff, this particular one is set to harden fast, which I like a lot, because I mean, you don't put glue on something for it not to hold together for about 20 minutes. You put it on it because you want those two parts to be together and never let go again. That's so romantic, actually. But I think, yep, it's still liquid. I mean, 5 minutes aren't over yet. Honestly, after 5 minutes, you can still kind of use it. It essentially turns into some kind of goo. Turns from what it is right now, which is essentially like jam, something that is a little bit like not so recently molten cheese, and then it only turns into anything resembling a solid. Let's... Well, hi, gaffer tape. Oh yeah, and now my headphones cable is falling. This is going splendidly. I don't know if you actually even see that. Oops, but I've got my headphones connected up to the camera, so you get somewhat of a good audio quality, unlike the stormy terribleness from last time. Oops. Gotta be careful, I don't want to glue my strings to the outside of the rocket. They're supposed to be inside of the rocket. That is that. Our rocket is a teeny tiny little bit longer. It looks wonky. What I'm doing now is I'm essentially just looking along the line against the wall, because that will reveal, yes, if and where to it is wonky. So obviously, as this is a rocket, I don't want to have it wonky. You just want it to be as straight as possible. And that's pretty much it. Now we only have to connect these strings back up, which is gonna be interesting because both of them are not that long, and I'm actually thinking about mixing in some more epoxy glue into that stringy fun, because what you can obviously also do is just put them together with knots and then really making the knots stay for the rest of their life by putting some epoxy glue on them. But let's first make some, oops. Let's first make some knots. I'm gonna push this back in there, so I first of all cannot forget to put it back on. Secondly, it's already out of the way, so it can't annoy me. Just gonna plunk it down on this thing so I can try to make a proper knot over here. which I'm never able to do. So, well, another time speed up incoming, I guess. Alright, so the second nut is nearly done, but it's still loose because now I really want to make sure that the strings are still kind of the same length here. Let's see if nothing is stuck in the rocket. No. And now I want to pull this nut shut. Yep. Because if I have two strings and one of them is longer than the other, then obviously that longer string is gonna carry all the weight when deploying the parachute, which is obviously not what I want, because that's why I have two strings. And in this case it's not that bad because technically our string up here is not connected firmly, it's loose, so it could balance itself out. But why would it ever do that if I just put the nut in the right place? I mean, that's not a hard thing to do, so why not just do that and be happy for the rest of your life? Not quite sure, but I think I'm see, that's what I mean, not so melted cheese. Yep, no, that stuff is already gone. So I'm gonna just mix a teeny tiny bit more of that stuff. Don't really need a lot of it, because unlike many glues, it doesn't shrink when it turns solid, because it doesn't dry. That's why I'm also not saying it dries, because, well, it doesn't. Because drying means that something would be evaporating, but it isn't. There's nothing evaporating in here. It's just a chemical reaction between all the components in here, with nothing evaporating whatsoever. So it doesn't dry, so it doesn't lose mass, and subsequently, and luckily, because obviously you have some chemical reactions that will change the density of the outcoming materials, that results of that reaction compared to what you put in. But in this case, it really isn't anything to worry about. It just turns a mess if you're too stupid. Alright, we still got some glue left, so what I'm gonna do is, my printer had a little hiccup over here. I'm gonna try to put some of that leftover glue into that groove, because it's quite a big one and I don't like it. It is not a question of aesthetics, but it's a question of if it works or not. And every groove in a material that carries load means that at that point there's, well, obviously less material that can carry the load, meaning that on the rest of the material there's even more strain. And, well, strain leads to failure, as Yoda once said. Okay, checking another time if it's still straight. I mean, fell over often enough. Then we're already good to go for another flight. Alright, so our rocket is loaded up with a B-44. I today got myself a cameraman, or a camera lady to be exact, so hopefully less shaking. If there's still shaking, that's her fault. Don't laugh, that will be shaking. Parachute to the left. So, a few things happened. The parachute deployed perfectly. The only issue is that it apparently is not connected to the rocket. So I'm not quite sure why that happened. There might be a few reasons. First reason is the parachute might have deployed far too late, or not might, it did. So either it burned through the ropes, that might be a possibility too, or it just deployed so late. The rocket was too fast and the parachute cords just ripped, so we're gonna go and see if we find the parachute. Actually no, because that's a quite annoying thing. The rocket landed in a field that is even more annoying to look in. So yeah, that's gonna be fun. Ticks, here we come. Ada, come here. In the end, we found both the rocket and the parachute. This is a bunch of burned string. I'm not quite sure if it's cotton or if it's polyester. For sure, it is burnt. Also, the bottom end of the parachute is molten and burnt. So this would lead to the conclusion that the rocket engine fired its charge to deploy the parachute up into the rocket, but the cotton I put in here to actually cushion this explosion did not work out, and it burned the parachute and the ropes holding the parachute, leading to it burning off and falling off into a different direction. So what I could do now is just replace the parachute. The only problem I see there is that this rocket turned out quite heavy. So in the end, I will probably just take this specific rocket and put it into my little rocket museum. I will also look into the 3D files of the rocket and maybe adjust some things, make the walls thinner, and redo the design of, for example, the tip to save some weight there as well. But that's a project for a different day. And just as a little teaser, I've got this right here, which doesn't even fit on the whole screen. This is my Ariane 5 rocket. It's a paper model, and I wonder if you could put actual rocket engines in there. Thanks for watching, and bye-bye!
Hi, it's Mortis from the future. If you want to see which rocket we're going to build next, just subscribe to the channel and hit the bell button. Also, if you want to read up on the whole project at Viventus, visit our webpage or our Facebook page. All the links are in the description below.